Hi everyone, welcome back to Maths with Mr. Yates, and today we're going to be continuing looking at cards, and in particular we're going to be looking at every deck of cards, or the number of different ways it is possible to arrange a deck of cards. So, how many ways is it possible to arrange our deck of cards? And just as a spoiler, it's a lot. And it's not just a lot. It is an absolutely enormous number. It is unfathomably huge. It's so huge that humans have a really hard time actually comprehending this number. But as this is maths, we're going to try comprehending it anyway. Now, just as a heads up, this video draws strongly from the following webpage. It's a great little read about the different ways we can visualize how big the number actually is of how many different ways we can arrange a deck of cards. Anyway, let's go. So first up, we're going to be talking a little bit about combinatorics. That's a fancy sounding word for something that sounds a whole lot less fancy, which is counting techniques. That may sound like a really mundane sort of thing to be learning about in maths, but it's actually quite fascinating and underpins a lot of probability, especially that involved in things like cards. So let's get into it. So if we have just 4 cards numbered 1, 2, 3, and 4, how many ways can you arrange them? And I've got all the different ways we can arrange them down here. All of these first ones have got 1 as the first card that's been picked. All of these second ones have 2 as our first card that's been picked, then 3, then 4. And it turns out that depending on which card we lock in as our first one, there are 6 different ways that we can go across from that, or 6 different ways we can arrange our 3 remaining cards. And for 4 different ways that we can choose our first card, we multiply that together. Hopefully you shouldn't have too much trouble multiplying that, but it ends up being 24. So with just 4 cards, that's quite a lot of different ways. If we're going to be calculating 52 cards, we're going to have to think, is there an easier way to calculate it? And yeah, it turns out there is. So let's have a look. Now let's think of it with our 4 cards just to start with. So with 4 cards, there are 4 different ways to choose the first card. So we could choose the number 1, 2, 3, or 4. So there's 4 different ways we can choose that first card. Here I've chosen the number 3. After you've chosen your first card, there are only 3 cards left. And that means there are 3 different ways to choose the second card, which means that for 2 cards, we do 4 options for the first and then 3 for the second. So we could do 4 times 3. And here I've chosen 2. So my options were 1, 2, or 4, as I'd already chosen 3. Here I've chosen 2. Now we choose the third card. There are only 2 cards left, 1 or 4 in my example. So I've got 2 choices. There are 2 different ways we can do it. And then my last one, there's no choice for my last one. It's just there on its own. Multiplying by 1 doesn't change our number, but we get 4 times 3 times 2 times 1. What does that add up to? 4 times 3 is 12, times 2 is 24. Multiplying by 1 doesn't change the number, so it still ends up being 24. So it's 24, just as we worked out above. Okay, fantastic. So we've got ourselves an easier way that we can count how many different ways to arrange something. And in maths, we use a special symbol. This is called the factorial operation to easily show these kinds of numbers. It would be a little bit tedious for every time to have to write out 4 times 3 times 2 times 1. So instead, we use this factorial symbol, 4 exclamation mark, and that means what we've got there. And in fact, if I pull out my little calculator, let's get that here. There we are. Most calculators, or most of these sort of these scientific calculators do actually have a factorial button there. I can put that in, and that gives me my number of 24. If you haven't known what that means, then that's what it's for. So that is that's what our factorial does. Now, how does this help us with cards? So the number of ways we can arrange a deck of cards is 52 factorial. Or, and this is where the exclamation symbol makes things easier for us. We could think of it as 52 times 51 times 50 times 49 times, well, you get the idea. So, how big is this number? Let's find out. So what I'm going to do is I'm going to put 52 and then an exclamation mark behind it in my calculator. And it gives me this absolutely enormous number. So it's approximately 8 times 10 to the power of 67. What number is that? That is 8 with 67 zeros after it. Or more specifically, it's that. That is not a small number. That is a big number. And the thing is, any number that's large enough is going to just start to look like someone mashed their hand on a computer keypad for a while. So it's really hard to understand exactly what this number means. We just don't understand it. We don't ever, in day-to-day life, come across numbers that are this huge. So we're going to put it into perspective. How long is 52 factorial seconds? How many seconds is that going to be? Let's try and work that out. So to help us realize how many seconds this is going to be, what we're going to do is I'm going to go for a walk. And it's going to be a long walk. We're going to walk all the way around the equator of the Earth. And it's going to be a leisurely walk. I'm going to take my time. I'm only going to take one step every billion years. So, how many seconds do you think it would take to get all the way around the Earth? You can try and work that out. But here we go. We're walking around the Earth gradually. So, there we go. When I've walked all the way around the Earth, I'm going to take a drop of water out of the Pacific Ocean here. Great. So I've taken a drop of water out of the Pacific Ocean. And then I'm going to walk around the Earth again. So I'm going to highlight that in blue just to sort of highlight what's going on here. Then I'm going to walk around the Earth again at the same pace. So I've walked around the Earth, taking a step every billion years, taken one drop out. I've walked around the Earth, and I'm going to take another drop of water out of the Pacific Ocean. So I've walked around, taken another drop, and I'm going to keep doing this until the Pacific Ocean is completely drained of water. So there's no water left in there whatsoever. Whew, nearly done, right? Not even close, unfortunately. So what I'm going to do is I'm going to slap a sheet of paper on the ground, and I'm going to fill the Pacific Ocean back up with water. And I'm going to start walking again. So I circumnavigate the Earth. Each time I circumnavigate the Earth, I'm going to take a drop of water out of the Pacific. And then after I'm done, I'm going to put a second sheet of paper on top of the first, after I've completely drained the Pacific again. And I'm going to repeat this. And I'm going to repeat this until there is a stack of paper that reaches from the Earth all the way to the sun. Great. Am I nearly done? No, not even close. I take that stack of papers down and do all of it again. And I don't do it just once. I have to do it 3,014 additional times. And that is about how long it would take to run down a timer going for 52 factorial seconds. Now, this is just an unfathomably huge number. It's really hard to get across exactly how large this number really is. And this number itself, this number of seconds, this is much, much longer than we expect the universe to even last. The Earth itself will be engulfed by our own dying sun before we even got out the front door, because that's going to happen, I think, in about 5 billion years, and that's about 5 steps. So much longer before all of these seconds have passed. It's going to be pretty close to the end of the universe, or at least the end of humans in the universe. This is what makes cards so good for playing games. No matter how many times you play with a game of cards, it is astronomically unlikely you will ever play the same deck twice, unless of course it's rigged or it's just badly shuffled. So you can go forth and play a game of cards, play as many games of cards as you want, confident in the knowledge that you'll never play the same game twice. Happy gaming. So, no game for us this week, but next week I'm going to try and find one of my favourite games, in fact, that you can play with a deck of cards. So we're going to be having a look at that one. Anyway, I hope you've enjoyed this video, and see you next time. Bye.